Welcome to ePathshala lecture series in computer science, and this is a course in cloud computing. And today we are going to talk about the cloud architecture and the deployment models. So today's learning objectives are, first we will look at the architecture, and then we will see how the service models are part of this architecture and what roles do they play. We will also look at the deployment models and see that how these deployment models are used by various actors in the scenario of cloud computing. And to understand this whole environment, we will look at some case studies. So, the cloud architecture, when we say it is an architecture of cloud, what we mean is essentially there are two components in that. One is the stack, cloud stack, which is being used by the various entities in the environment, and the other is the set of actors or groups of people groups of people who together create and use this environment or maintain and manage also. So, we look at these in right now in this module. So, this is the cloud stack. This cloud stack contains various parts. We will discuss about that a little later. Let us move on and look at the various actors that are there in this cloud that are using this cloud stack. The first one is the provider. Now, we have put the stack inside the provider's entity because the complete creating and maintaining the cloud stack is done by the provider. So, the first actor in our cloud environment or architecture is the cloud service provider, and this provider maintains the cloud stack. Next comes the very important part of the cloud environment are the cloud consumers. They consume the facilities provided by the cloud stack and the service provider. Then comes the broker. A cloud broker is like in any normal broker who mediate between two parties. So, one is say if we take real estate, then we have a person who has a house and there is another person who wants to buy the house. They do not know each other, they come through a broker, and the broker is a person who knows both the person having the house and who is trying to buy it, and this broker mediates this transaction. So, similarly in a cloud environment, we have a cloud service provider who has to provide the service, and we have a cloud service consumer who will want to consume the service. To mediate between these two, we have a entity called a broker entity. We have an auditor who has to audit the correctness of this environment, and we have a carrier who is responsible for carrying the transporting the all the required messages. We will look into them in details now. So, let us start with the service provider. What are the responsibilities of the service provider is manages the stack in the sense that they create the stack. They create all the resources that are part of the stack. Then they create the services and then makes the services available to the user. They manage the overall service, security and privacy. The next one are the consumer. The job of the consumer is to see what are the services available. So, they must know where the catalog is available and browse through the catalog. They request a service based on their requirement. They request a service, and as soon as they request a service, a contract between the provider and the consumer has to be created. And this SLA it stands for service level agreement. There has to be a contract, a written contract between the provider and the consumer, which has to be respected by both the parties, is set up. and then the cloud consumer will use the service, and of course, as soon as they have used the service, they have to make the corresponding payment for it. So, these are the roles of the consumer. Now, what are the roles of the broker? The broker's role is to negotiate or mediate between the provider and the consumer, and service intermediation. Some service may be available somewhere, some other service may be available somewhere else. That kind of help also cloud brokers do. Actually, in cloud environment, recently cloud brokers have obtained a very much more important role because of a new concept which is called a federated cloud. In a federated cloud environment, so many different cloud providers are coming together, and together they are trying to satisfy the needs of the cloud consumer. There the role of the broker is more prominent than a normal than a single cloud. The next actor is our auditor. So, the responsibilities of our auditor is to conduct independent audit, independent assessment of the services, whether the services are good enough, whether their quality is good, whether the prices that they are charging, the providers are charging is correct, etc., are to be done by the auditor. Also, the security audit. A very important part is that when I store my data in cloud, is my data safe? And the provider will say yes, the data is safe. The consumer may not have the confidence in the provider, and this has been a point of concern from the day one of a cloud environment that has been proposed. So, very easy way to resolve this is to have an independent auditor auditing the cloud environment, and also the privacy audit. Is my data being maintained the way I have set up an SLA for? The last but not the least is the carrier who has to carry the transport the messages and the packets that are relevant for the for providing the service by the provider to the consumer. So, they maintain the connectivity, they provide the connectivity, they maintain the connectivity, and they carry all the necessary required packets that have to be carried between these two entities. So, once we have looked at all the actors, now let us go back and look at the detail of the cloud stack. So, in the stack, the first part is the physical layer, where all the required hardware are kept. So, these hardware will be your individual machines, the clusters, the networking components, the storage components. All these components will be stored in the physical layer. These are our data centers. They consist of thousands of nodes grouped together, that is the data center. We learned that there could be a centralized clusters in data centers, or there could be a P2P cloud where there are many nodes, but all these 1000 nodes form the this lower layer of the cloud stack. They are responsible for providing the physical hardware, the devices, and they are responsible for communication between the devices and the higher layer. The next layer in the cloud stack is the virtualization layer. We have studied virtualization in earlier modules extensively, and here we see the use of that in cloud is that it sits on top of the hardware, and it has a virtualization layer, and it has a set of virtual machines that are generated by this. This virtual machine, this layer has, it is the enabling technology, as we said, it is the key enabling technology, and this layer creates a pool of virtual machines, and these virtual machines will be used by the users in some form or other. Now, this layer of virtual machine forms the first service model, which is the infrastructure as a service model. So, when uses the service of infrastructure, they will be given these virtual machines and they will install their own operating system, their own software in these virtual machines and behave as if the underlying hardware is being accessed through these virtual machines. So, they rent the infrastructure which is the underlying layer, but they in reality they rent the virtual machines which represent the underlying hardware. So, this is the IaaS layer that is created. Next in the stack comes the platform layer, where all the software relevant to create the middleware are kept. We have the MySQL kind of software, we have the Hadoop kind of software, we have all the compilers, all the system softwares that are available. Everything will be there in this platform layer of the stack, and the service that is given to the users is platform as a service when these are borrowed by the user. So, they do not borrow the infrastructure, they borrow the platform which contains certain software as per their requirement on top of the specification of hardware as per their requirement given by virtual machines, and they will use the platform, and therefore, this service is called a platform as a service or PaaS. Last but not the least is the application layer, where all the application software will be installed or stored in the stack, which will be all your any other software that organization will use, or even simple basic software like Word or PowerPoint. And this layer is the is used by the users perhaps the maximum, where applications will be given as a service, and this is called software as a service. So, the cloud stack consists of the physical layer and the service layers. Together in between the sandwiched is the virtualization layer. So, using these three layers the stack is maintained. So, now we start with the cloud service layers, and in this layer we have the consumer consuming the service through various mechanisms like a web browser or a mobile app or a thin client, and we have the services IaaS, which is the through VM the hardware, PaaS where again through VM the platforms are given, or the SaaS where we have the email, ERP, games or simple PowerPoint etc. software available. And when the user wants infrastructure, they access the IaaS service. When they want certain platforms, they use the PaaS service, and when they want some software, they use the or application, they use the SaaS service. So, these are the three service models used in a cloud environment. Each service layer supports, each lower service layer supports the higher service layer in the system. So, therefore, IaaS supports PaaS and SaaS, and PaaS supports SaaS and so on. Now, let us look at the deployment models. How does a cloud provider provide services to the consumers? So, in what way they create their service? We already have seen in the earlier models that there is a public cloud where all the facilities are generated for the average public and even for some enterprises. So, anybody can access a public cloud, and at a pay per use basis they can on demand, they can access whatever services are available. We have private cloud. The enterprises organizations have sensitive data that they are not able to share in a public environment out of fear. So, they will create a cloud of their own for their employees and for their personal usage, and typically this will be an on-premise cloud. Not always they will have all the resources in their premise, but still it behaves like an on-premise cloud. So another organization will have their own private cloud, and so on. The next one is a hybrid cloud. Whenever they have a private cloud, that may not be sufficient for the use of the organization. There will be situations where they will need to access a public cloud as well. So, typically what they will do is they will keep their sensitive data in the private cloud, and they will keep their less sensitive general data in the public cloud, and they will use these two. So, that forms a hybrid cloud where both public and private access is available to a specific enterprise. So, this is what hybrid cloud is all about. Then sometimes it so happens that two or more organizations want to share something, want to share their work, their projects, their data, etc. But they have some sensitive data. Now, if they have a private cloud, any one of the organizations having a private cloud, the other organization cannot access it, because there will be even more sensitive data that this organization does not want to share. But there is some data which both the organizations want to share, but they do not want to share it with the other public. So, that is the case when they create a community cloud. So, say this enterprise and this enterprise together, they want to share some data, do not want to make it public. So, they together create what is known as a community cloud, which is accessible to the employees and the users belonging to these two organizations. So, this is called a community cloud. Let us now understand how these cloud work, how these models work, given an example. So, we have taken a few case studies. The first case study has this organization XYZ, which is basically a startup organization. They do not have too much of money to invest in infrastructure, but their job is to develop and sell software. To develop a software, they need the hardware, they need servers, they need networking mechanisms, they need their specific softwares, everything is required, but they do not have that much of money. They manage with some resources they have, but at suddenly if they get a very big order to develop a very large website, they face the problem that they do not have the infrastructure, neither do they have the employees. So, they hire 30 employees for this web development project. What about the infrastructure? So, this is a small business suddenly getting a large project. What are the options? So, let us look at the constraints that this organization has. It has to hire 30 employees, but it has a budget constraint. Acquiring a space for new servers, they need new servers. Buying the new servers alone is not enough, they need a space where these servers will be located. Then buying these high-end servers and hiring staff, not really to develop, for development they have to hire. What about maintaining the servers? That also they need to hire staff for. And then buying the software, the operating system and any other software that they are going to use. With all these will require a lot of investment, the money for which they do not have. So, what happens as a solution, what is a possibility as a solution is what is called a public IaaS cloud. So, in this public IaaS cloud, what happens? Let us look at that. So, this is a cloud. It can be an Amazon cloud, or it can be any Salesforce cloud, or Rackspace cloud, or any cloud which suits their pricing mechanism, and the team leader will first create an account with that cloud. Then he or she will choose the specific virtual machine images or virtual machines that is required for their work, or they will ask the provider to create a virtual machine, and then she will decide how many virtual machines will be required for her project, and then she will choose the specific type of virtual machine. Now, there are various types, and pricing and the usage will vary depending on the virtual types. Let us take a quick look at the virtual machines. Virtual machines are through which these infrastructure resources will be offered. So, it can have only OS in the virtual machine, or even without anything, a bare virtual machine also is possible, or a pre-packaged virtual machine containing all the other software. And what are the possible types of virtual machines that are available? There are on-demand instances. Suddenly I need 20 VMs. So, therefore, on hourly basis I will pay for it. It is not a long term, it is a short term commitment. Then there are reserved instances. I know tomorrow for the whole day I will need 5 VMs. So, since I will be reserving these resources from the provider, providers tend to give better rates for your VMs, and the reservation, the capacity will be reserved in the VM. So, assured access to the VMs will be by this reserved instances. The problem of having reserved instances is not always the business is guaranteed on these smaller organizations, and therefore, it is not really always possible to have a reserved instances. And the third variety, which has been introduced by Amazon some time back, are called spot instances, which will be significantly less costly for the users, but it will be based on the availability. So, there is no guarantee that the spot instance will be available. If a spot instance is available, the user can use it, can take it and use it. Problem of using this kind of spot instance is that the provider reserves the right to preempt a service at any point in time. The price will be based on, typically it is auctioned, the spot instances will be auctioned and the best bidder will be given a specific instance. So, these are the possible options for virtual machine. So, we create a virtual machine and then launch it, which is basically a pending state, and then it goes to the running state. It is basically a waiting state. If we map it to a process life cycle, then this is the creation, and then this is the waiting state, and this is the running state. When it is over, we stop the virtual machine, and then we again want to restart a stopped virtual machine and put it back to the pending state. Sometimes if it gives a problem, we can reboot a virtual machine. It is supposed to do something it does not do properly. We reboot a virtual machine just like a normal machine, and when the life of that virtual machine is over for whatever reason, we do a shutdown and terminate the virtual machine. Even from the stopped state, it is possible to terminate the virtual machine. This is a life cycle given by Amazon Web Services. So, we go back to our discussion of what happens to this team leader when she wants to hire a set of virtual machines infrastructure from a public cloud. So, she chooses the specific virtual machine type, and then she sets the necessary configurations for her team to use, and then informs these virtual machines are launched, and they are her team will be informed that these virtual machines are ready to use, and the team will be accessing the virtual machine, and now only the development for that website will start by XYZ. So, this is one way of looking at why or when a particular company wants to access the So, in architecture, what does the service provider do when they have an IaaS? They manage the overall service. So, what are the things that they are managing? The physical layer is being managed, the infrastructure management layer having all the scheduler, monitoring, resource providing, QoS, SLA will be managed, and then the last but not the least will be access the infrastructure through web services portals and REST API. So, this is the IaaS architecture. Let us take a second case study where this XYZ firm has grown, they have bought certain resources, they have increased their revenues, but they continue to use a public cloud, but now they have some infrastructure in their premises or maybe in different places. Suddenly, this firm gets a project which requires them to have sensitive data. A sensitive data, they have to ensure that they store it on premise and does not allow outside. So, the data is sensitive, therefore, usage of public cloud is not possible. So, the organization is in the need for creating their own infrastructure. But what are the concerns? The cost. Do they buy everything new, or can they use the scattered infrastructures that they already have? How to optimize that? Power consumption and data center management, of course, the additional expenditure. So, what is the solution? Now, they create using their own infrastructure or maybe adding a few more, what is known as a private IaaS cloud. Moving from the infrastructure of scattered infrastructure everywhere to the private cloud, they are from the physical, they are moving to a virtual world. So, before this, all their infrastructures were being used by individuals directly. People were logging on to a machine, they were using a client server architecture, but this is physical to virtual, dedicated. So, a machine belonged to somebody. Now, it is a shared environment among the organization people. Manual management. So, I would physically shut down a server, I will physically power up a server. Now, it is an automated management and IT managed versus self-service. So, when they move to the cloud, they have to do these kind of adjustments. So, this is the setup where this IT team first sets a cloud infrastructure. They consolidate all the infrastructure available and they create a cloud, a private cloud out of it. Then they set up a self-service portal or a dashboard, and then the cloud admin, somebody has to be defined as an admin, and this admin will test the environment through self-service. And then now there comes the project team who will be obtaining the virtual machines. Only difference is now the virtual machine resides in the private cloud in premise, and they will use and develop their application. The cloud admin continues to manage the environment and adjust the capacity. This is the way a private IaaS cloud has been is being set up by this company XYZ. We continue our case studies in the next module, and we summarize this module like this. We looked at the architecture of cloud, where we saw that cloud stack and actors are there. We looked at the service models, we looked at the deployment models, and we looked at two case studies where we saw IaaS in public and private. In the next class, we look at some more case studies, and then we move on to the next important part of cloud computing, which is scheduling. These are our references. Thank you.